Okay, now I want you to try it on your own. And this one, it tells you to dilate with the scale factor of 1/4. Okay, so the scale factor is 1/4. So that means you'll multiply every single coordinate point by 1/4. Pause this, answer 9 and 10. Try to answer 10. We'll come back and talk about it. And remember, this is around the center of the origin because it only has this here. Okay, we'll talk about the other one later. Pause it, see what you get. So by the time you multiplied or applied this scale factor to every single one of these points, then hopefully you would got your r to or p prime to equal 2, 1, your q prime to equal 3, negative 1, and then your r prime to equal negative 1, 0. And this distance is number 10 talks about the distance from the origin, each image point related to the distance corresponding pre-image point. So each image is 1/4 as far from the origin as the corresponding pre-image point. Okay, I'm about ready to pause this and show you what the new image is going to look like on the graph. So if you graph this new scale factor 1/4 of the way dilation, this is what the one in red here should look like. That's what your new your image is going to be after applying the scale factor. So now we're going to go to the next one. Okay, now you notice too, I've already got some things written down. I want you guys to write down as well. Okay, so the first thing is how far are all the points, looks like I write pants, but how long are all the points away from R? Okay, and the reason why I select R is because of this right here, the dilated center. Okay, the dilated center, this is saying R. Okay, so that's kind of where the center of everything is going to be located. So everything is going to be based off the location of R. Okay, now the 1/2 in front, that is the scale factor. Okay, so that's going to be how big or small the image is going to be. Okay, so I answered number 1 for you. It said, how far are all the points away from R? So Q didn't go left or right any, but it went up 8. Or, yeah, it's a down 8 from R. Okay, so now the change of S is basically to the right, or it goes to the left from S to R is 6. Now T, it goes to the left 6, and then up 8 to get to R. So that's where I get these changes. Okay, the change, these are all away from R. Okay, so all of these is the distance away from R. If you haven't written this down, all this stuff down right now, do so. Or rewind or something, because I'm going to pause this, erase it, and then start answering more of the questions. Okay, so now I applied the scale factor. I applied this 1/2 to all of the changes. Okay, so this new Q right here, 0, -8, is now 0, -4. The new S is basically times 1/2 times the -6, got -3, times the 1/2 times the 0, got 0, times the 1/2 times -6, got -3, times the 1/2 times the -8, and got -4. Okay, so all I did was just take this scale factor and apply it to all of the changes here. Okay, applied it to all of those. Okay, now where the next thing, it says combine the new change, which is what this is. This is the new change, and apply it to the dilated center. Okay, remember the dilated center, if you rewind, is let me pause it for a second. I'll show you. The dilated center is this second portion of the vertices that I just circled in purple here. This is the dilated center. So what we're going to do is we're going to apply this to the R. Okay, we'll apply each one of these to the R that I circled, and that's going to be our new Q, new S, and new T. Okay, I'm gonna pause, erase this, and come back with the answers. All right, so you notice that this is R is this right here. Okay, -2, -7. So to get Q, I apply 0, 4 to this. Okay, 0 next, so we have -2 and a 0 equals -2. Then we have -7 plus 4, and we end up with -3. So all we're doing is just combining almost like a translation to this. Okay, so now I'm going to do the same thing with the S. Okay, so they have the -3 to the -2, so -2, and so the -2 and the -3 is equal to. Sorry. Let me pause this for a second. Sorry, I made a small mistake, and I can't go back and re-edit this. So what I changed was the S, what says -3, or the S was a -6. Well, R goes to the right to S, so that's a +6 change. So it went to the right 6 times. And you notice too, I changed it here as well because from R to T, you have to go 6 to the right, 8 down. That's where that comes from. Okay. So now when we apply this, we have our so we have -2 from our R plus 3 that we got from the S, and we get a +1. So now we go to the -7 and apply the 0 to it. So it's still just going to be, I said -7, but 7. Okay, so from here now let's deal with our T. Okay, so T is, remember this got changed to a positive, so we apply this -2 to this +3, so T is going to equal 1, and then we have the 7 plus a -4, which makes it a +3, so that's your new T. By the way, this is S. Okay, so those are going to be our 3 new points. And then I'm going to apply them. Let me pause it. I'm going to apply them up to the screen above, or the figure above. So now I just took our new points and applied it to this, to the new new figure above. So now this is what our new rectangle is going to look like, while being half as big, centered around R. Okay, this is the confusing one. This is the one that's going to take more time to learn how to do and more practice on. Okay, the one above, not that hard. This one, a little more difficult. Okay, you try it. Okay, and first of all, saying what is the center of dilation? Okay, so the center of dilation in this one, you'll notice that A and A prime is in the same spot. Okay, so that's where the center is. Okay, so the center is at what coordinate? I'll go ahead and help you out with that one. The coordinate of this, which is where both of them start, is -2, 1. Okay, so now you try to figure out the scale factor from this. Okay, so I'm going to go ahead and kind of help you out with this one too. So this one, to figure this out, now normally in the last one it's easy because we had straight lines. We don't have straight lines in this problem, okay? We don't have anything that goes straight on the coordinates, okay? So to find the scale factor of this is difficult because we have diagonal lines. So we'd have to use the distance formula. And in that situation is you would have to do the long formula okay, and then do the pre-image over the image, and then that's what you end up getting. Okay, just so happens in this one, it's going to be 3 over 2. Okay, it'd be a long way to go. So I'll just go ahead and help you out with that one. So in this, we have a blueprint of, that is 1/50 of the scale of the actual library or the reading space that we're going to use. Since Mr. Ayers is going to measure the reading space of the blueprint, find the actual dimensions and area so he can order the furniture. Okay, so you have to know, so you take the map of the blueprint. If you know what the scale factor is, how much smaller it is than the actual room itself, then you can learn how to measure the area of the space, the area of your furniture. That way you know what kind of furniture can you put in without actually having to put the furniture in. Okay, so in this it says it's 1/50th of the scale, so you'll have to read how big the dimensions are. So it looks like it's 14 wide. Okay, so it's 14 by 12. Now notice, so in order to do that, we need to set up a ratio. Okay, so we'd have 14 over x is equal to 1 over 50. Okay, take your scale factor, then we cross multiply. So we end up with x is equal to, and you do 14 times 50, you end up with equals 700. Okay, notice how I set this up. This is the pre over image, pre over image. Okay, and do the same with that as well. Now let's do the same thing with the other dimensions as well. So we said up here it was at 12 inches. Okay, so we set up the exact same way. So we end up with 12 over x is equal to 1 over 50. Cross multiply, and you end up with x is equal to, or we should say, probably call this y. That way we don't have two x's. So in this one situation, y is going to equal 600. So the dimensions are now actually 700 by 600. Okay, and this is probably 600 centimeters in this problem. Now that we know that this is a 600 by 700, to find the area, we would just multiply that. And when we do, we get 420,000 centimeters. So we want to change this and put this into meters. So basically you do this from centimeter to meter. It is basically 100 to 1. So basically you just do 420,000 divided by 100, and you end up with 42,000 meters. Actually, what you could do as well is go ahead and translate this to meters already, so you end up with 6 by 7. Okay, so you divide both of these by 100. So you end up with 42 meters squared is the area of the actual reading space. Okay, and that's what this is over here. It says, how does that actually relate to the area of on the blueprint? You notice that the space, actual space, is 2,500 times bigger than blueprint. And I don't know how to spell blueprint. Okay, you try 15, 16, and 17. I'll come back with the answer. Alright, so I'm starting to run out of time a little bit, so you'll notice that I changed the centimeters to meters, and I set it up the other way because this is the new image. Okay, that's the image after. That's the actual image. Okay, the one below it, I'm running out of time. In there, and I'll start a new one. Dang it.